Okay, good stuff. Let me get the screen back up here. All right, so the audio recording will be published shortly after the presentation now that I've started it on a different machine, so sorry about that. All right, so what are we here for? We're going to talk a little bit about unit testing AngularJS applications. And in particular, we're going to talk about Jasmine as a unit test framework, and then using Jasmine with Angular, in particular with a framework called Angular Mocks, and we'll also have a quick look at end-to-end testing with the Protractor package, and then we'll just mention our offerings, and actually I'll just mention the offerings right now. This material is actually drawn from our new a fairly new course, WA 2505 Comprehensive AngularJS Programming, which is a 5-day course which covers introduction to AngularJS, covers build tools, covers the background on JavaScript that you really need for working effectively with AngularJS, and some of the more advanced AngularJS programming techniques like custom directives, accessing back-end web services, structuring your application appropriately using compiled templates and a number of things like that. So quite a good course. And just along those lines, also mention we have an introduction to AngularJS, which has been very popular, WA 2425, which is a 3-day course. I'm actually teaching it next week as a virtual course, so if you wanted to take that, it's a live virtual course, and pretty sure you still have time to register. Some of you may be in it, but that's a very popular course that gives you a thorough introduction to AngularJS, gets you started with the framework and building applications, so that's good. Also, relatively new. I know I personally haven't taught it yet, but I'm going to be teaching it in July, I think, end of July, is the Angular 2 programming course. Of course, AngularJS, it's kind of somewhat controversial version 2 has come out, and we'll be covering that in WA 2533. Okay, so without further ado, let's talk about, we'll get back to that. Let's talk about Angular or unit testing with AngularJS. By the way, my name is Greg Trasick, and I've been teaching with WebAge for, I don't know, getting towards 16 or 17 years now, so a fair bit of experience going back. All right, so a couple of things we'll talk about. First off, Jasmine, and we'll talk about the Jasmine JavaScript testing framework and how we structure tests or specifications, as they're called in Jasmine, and then we'll look at applying that to testing AngularJS. Okay, so what's Jasmine? Jasmine is a powerful testing framework. It's written in JavaScript, and it is referred to as a behavior-driven testing framework or behavior-driven development. And of course, you may be familiar with unit testing, and we called this webinar unit testing in the first place, but you know, behavior-driven development is an extension of unit testing. And behavior-driven development is kind of a funny thing, and I'll be totally open with you. I'm not entirely sold on it being particularly different from unit testing myself. But anyway, the idea with behavior-driven development is that we start not just writing tests first, but we write our tests in such a way and using an appropriate language or domain-specific language, for lack of a better word, that describes the behavior of our system. So a behavior-driven test, or a test that we write with Jasmine, we don't actually call it a test, we call it a spec. and it looks a little different from a traditional, JUnit style test or JS unit style test. And we'll have a look at that in a minute. But it's written in such a way that it's intended to describe the behavior, and kind of the testing happens as a side effect of the behavior. And the idea is to make the description readable on its own, and also directly translatable from a sort of an operational specification. Right? And depending on where you're coming from, myself, I used JUnit and unit testing for probably 12 years before I jumped into the behavioral-driven style, and I just kind of find the syntax a little more convoluted than it needs to be. But other people may differ. So we're going to have a look at Jasmine. Jasmine is one of the more popular testing frameworks for JavaScript, and of course Angular is mainly JavaScript development. It's probably more JavaScript than HTML. There are a few other testing frameworks out there, Mocha and Chai and so on. I haven't found, I've looked at a few other frameworks, and I guess probably the way to put it, Jasmine happens to be the one that I came upon first, and I kind of got used to it. And I haven't seen any strong arguments for switching off it, but that's not to say that if you're using Mocha or Chai, you might find it kind of similar as well. And in fact, the tests end up being phrased in a fairly similar way. So Jasmine is kind of neat. It can be run in a browser, and we'll demonstrate it here running in a browser environment. But it's also possible to run it under an automated environment such as Node.js. And in fact, if you're programming in Angular, I suppose technically you don't need anything besides a browser. And in fact, when we do the Introduction to Angular course, we just use the browser and a text editor and an Apache web server. But really, if you're developing in JavaScript, it usually isn't too long before you want to use some more advanced tools, and you end up using Node.js anyway. So with Jasmine, we can actually put our specs into a file and run it from the command line, so we can run it under the Node.js. So we don't actually have to fire up a browser, and it's less manual. And of course, that integrates with continuous integrations. There's a lot of things that come into it. And that's one of the reasons we kind of like Angular, is that the way the controllers and services are written, they are amenable to being unit tested and hence included in continuous integration. Jasmine itself is self-contained, doesn't depend on any other JavaScript frameworks for its functionality. You can extend it, as we'll see, and it's available. It's on GitHub, jasmine.github.io. There's a standalone download. There are also a number of other integrations. I just mentioned the Node.js integration, so you can run it under Node.js. There is actually a Maven plugin which will run Jasmine specs, and if you happen to be using Ruby or Scala or Django or Perl or whatever, you can build it. And the scenario there is kind of the idea where you've got a back-end service that's written in your language of choice or your back-end application. For instance, if we're writing a web app these days, we might be using a Java EE6 back-end that's primarily using RESTful services built with the JAX-RS specification. But the front end perhaps is Angular, and maybe we put them all together. And the idea with the integrations is that we can have one continuous integration system run both the Java test with JUnit and also the JavaScript test using Jasmine. And if our build system happens to be Maven, there you go. If our build system happens to be Gulp or Grunt, well, they're supported in Jasmine as well. And there's all kinds of debates and discussions around how to structure a project. Do I actually want the front end in the same compile system or the same module as the back end? And that's a whole different set of discussions. But Jasmine does integrate with a number of different environments. Okay, we'll take a look at standalone mode. And standalone mode is easy to get started with. Great to learn the Jasmine API. In the end, you probably will want to use some language level integration. Myself, I tend to, and like a lot of web developers, or like a lot of people find, when you're kind of in the mindset of developing under Angular and working that, you tend to get into kind of a JavaScript frame of mind, and we end up using Node.js. And that's where we see large amounts of growth in what we're calling the mean stack, Mongo Enterprise or Mongo Express, Angular and Node. So everything is in JavaScript, and we're running the back end under Node and the front end under Angular. So that's probably where you end up, but for the purposes of this discussion, we'll take a look at Jasmine just running in the standalone mode. And essentially, with the standalone mode, we'll end up, and let me just bring up a little display here. Here you can see I've got a unit testing Angular folder that I opened up in my current editor of choice, which is GitHub's Atom. And we've got a lib directory where I downloaded Jasmine, and I've got lib Jasmine 2.1, and I've also got the specs, which is going to be our specifications, and I have some source for some code. And I also have here, we'll see a little later on, I have an actual Angular application that will fire up, and that's in my app root directory here. And the core thing from the point of view of running Jasmine in standalone mode is this spec runner. So what we have is an HTML file which loads up the specifications, right? Loads up in the beginning Jasmine itself, Jasmine CSS, and then the Jasmine JavaScript, and then we load up our JavaScript files that we're going to be testing, and then we have some specs. Okay, and in the end, if I just pull out spec runner, I'm not sure which one. Yeah, okay, so I've just for the sake of argument here, I loaded this up, and you'll see the URL is localhost 3000 spec runner HTML. You may recognize that as I have run this inside a little self-contained Express web app running under Node. So if I hit specrunner.html, we can see I get a page from Jasmine, and it's telling me 10 specs, 0 failures. We'll take a look at that in a minute. So, our Jasmine folder structure, we have a lib, we have source, we have specs. Lib is where the JavaScript for the actual Jasmine framework is. Source is where the JavaScript files are that we're going to test. Spec is where our specifications or unit test specs are resident. Okay. The spec runner page is this, HTML page that is actually running the specs, right? It's JavaScript, we run it inside the browser. And we're loading that, and as we said, we have to, that we'll edit that to add specifications and call out the files that we're building. Now, a little bit later on, we're going to talk about testing Angular, and we'll see that we make a couple of modifications to this spec runner for the purposes of mocking out the Angular framework, but we'll see that in a minute. So we include the application files and the unit test files. All right, and then the test results, after we load the spec runner on the page, Jasmine will run all the tests and display the results, and that's what we saw here. I can probably make that a little bigger for you. Okay. All right, right now I've got 10 specs and 0 failures, so we'll get to simulating a failure. Okay. The actual Jasmine test specification or test suite is in, well, Jasmine calls it a spec, and it is defined with the describe function. And let's just go take a look at some actual code here. Here is a sample of the test spec. Okay, and here's what I'm talking about when I say behavioral-driven code or behavioral-driven development seeks to describe the behavior and then test that we meet the behavior. And this is intended to read as more or less plain English statements. So we read this as, excuse me, we're describing the example on page 12, and it passes an increment test, and I read this as where I run this code, and I'm expecting some function result to equal 1001. Okay, so here's my, in JavaScript, I defined a test function, and then I'm expecting the test function result to equal 1001. So it's intended to read as a description of the behavior of this component. So the example on page 12 passes an increment test and fails a simple math test. Okay, the semantics of it can be flipped around, whatever. Let me just, I'll save this so that we actually see what a failure looks like. So save that, and let me go over here and we'll refresh the spec runner. Now I have a failure. Okay, and I can see that I have a stack trace, and I've got page 12 fails a simple math test, expected 1010 to be 10101. Okay, and then you can go look at it in detail, one failure, etc. And we can rerun all of them whenever we'd like. Okay, so the test suite is what's contained in that describe function, and it's intended to contain all the descriptions of the behavior. And if we look at what that is, in actual fact, the describe function, we give it a string, which is a string description, which, doesn't take a lot of imagination to realize that comes out as the description that's used. And then we have a function, and like a lot of things in JavaScript, we use deferred execution, so that function is going to be called at an appropriate time by the Jasmine framework to define the other expectations. Okay, and then each one of these phrases here, it, and like I say, this is a thing that kind of seems funny. What do you mean it? When you're looking at it or when you're starting out, but think of it as a description in English. We're describing the example on page 12. First step, it passes an incremental test. Second thing, it fails a simple math test. Okay, that's why it's it and not this or assert or whatever. So it passes an incremental test, and then we're providing a function that is going to be executed to validate the test, to validate the behavior. So that's the actual test function in there. And the suite is all of the assertions about the behavior. Okay. So in Jasmine, unit tests are referred to as a spec. Specs are defined by the it function. It takes a string and a function that's going to be run. Now, of course, this is in fact a JavaScript function. So this function forms a closure around anything that is lexically accessible to it. So if I had a var a equals 5, I could say var to equal A, and this internal function has access to that. I suppose that should be actually indented. Has access to that variable that's defined in the closure, right? And if I were to run that, I think it should. Now I should have two failed specs, right? Two failures. And I could say A equals 1001, etc. Right now that becomes important because what we're going to end up with is, back to one failure, we're going to end up using that to set up the test harness. Okay, so variables declared in the parent describe function are visible in the unit test because it's just a plain JavaScript closure, and spec is a container for one or more assertions about the behavior of the object we're testing. And we express that behavior instead of an assert function, or instead of using an if statement, we express that with expect. And the idea with the expect, these are called matchers, and the expect statement is intended to read a little bit more directly so that the intention of the test is more direct. And you can be the judge of whether you find that to be the case or if you find it just to be verbose. You might pick up on the fact that after writing JUnit specs for untold years, I find the syntax a little verbose, but it's the way everything's going these days. So that's life. So we say expect, and we have a value, and then we have some description about it. So that's the matcher to be, or there are other matchers as well. Okay. Matchers that are included with Jasmine are to be close to be defined, to be falsy. And again, it's expected or trying to express the actual requirements, okay? So for instance, if I'm testing a floating point value, I really can't test equality in a floating point value because the bit round off never quite works, and it makes for fragile code. So if you're going to do it right, and I want to see if I divide calculate the hypotenuse or the distance of something on a map or something, and it should be 15 miles. If I was going to do that right, I assign a tolerance to it and test whether it is greater than 14.9 miles or kilometers and less than 15.1 kilometers. Well, that's what we say when we say to be close to. So, the idea with the matchers is that I can express directly, expect the calculated value to be close to 15, etc. And then we get some funny things that are kind of JavaScript oriented, so to be truthy or to be falsy. And that reflects the fact that JavaScript does a lot of cavalier conversions, and when we compare Booleans, a lot of things can end up looking true or false. So that kind of reflects that. To be falsy means to end up evaluating false according to the usual JavaScript conversions. And then you can create your own custom matchers if you wanted. So if you had some, application-specific value or application-specific representation, I could create a matcher that says, to match an APRS packet or something. And some of the more common ones, to be compares using the triple equal sign in JavaScript. To equal works for literals and variables. To match is used for regular expressions, and et cetera and so on. And you can see there's a number of them. So hit the Jasmine documentation for that. Okay, so here's an example of a spec used to test a function. That's actually what we've been looking at. So we do some calculation, and then the expectation is stated explicitly. So expect test function to equal 1001. Test function normally would be in a separate JavaScript file. If I'm testing that's part of the unit under test. But here we just defined it in line just to simplify things. So the expect function performs the expression evaluation. So you could have assertions. So you can expect 1000 plus 1 to equal 1001, etc. There's also a not property, so if I want to express the opposite, I can just use the expect whatever dot not dot to be false. And of course, because functions and variables are not that different in JavaScript, that actually works. The not is actually a function that returns an inversion. Yeah. Now, when we see test failures, we can see the stack trace and then pick out where the problem was, right? So here's a test that was packaged inside the test or spec.js suite, located in the file identified by specs.js, line 62, column 30, etc. And you can read that through the stack trace. Okay. Quite often, when we're testing, we might have what we'd call setup or teardown. Maybe if I'm testing a controller or whatever, I have to go get some values, or I have to prepare a mock object or whatever. So we have setup and teardown. This is code that is not really part of the description of behavior, but code that sets up the conditions to test the behavior. And we can do that in Jasmine with a so-called before each function and an after each function. So before each runs common setup, and what the framework will do is call before each in the context of the test harness before it runs every before it runs every expectation. So we put a before each and an after each inside a describe block, and then whatever function we provide through before each and after each will get executed whenever the it block is run. So that looks kind of like this. And it's probably worthwhile just reinforcing a little bit. And let me see if I can just get a highlighter here. Whoops. Highlighter here. There's a spotlight. Okay. I'd rather a highlighter. So what we are actually providing is a function. Okay. So it's not the before each function that's written here. We're not defining a function. We're calling the before each function and providing a function, and that function that we provide or that we pass into before each is going to get called before each test. Okay, and then if we want to disable the test suites, this looks a little funny, but instead of editing a configuration file or something, all we need to do, let's say I had this fails a simple math test. If I wanted to get rid of this, I just changed to the name X, so X-it. And what that will do is when I go and execute the spec, now I have 0 failures, but it does tell me that I have one spec that is not currently in use, temporarily disabled with X-it. Okay, so that way I don't have to comment anything out. I don't have to go edit a configuration file. I've just changed the name of the spec. And all that really happened is, there was an it function that's defined as part of Jasmine. There's also an X-it function, and it adds a test that's going to be run. X-it just adds a note that we have a test that's commented out. Right. And there's also an xdescribe if you want to get rid of a whole description. Okay, so another common thing that we want to do is simulate or plug into the behavior of an object. And this is a technique called a spy. Now, if you happen to use unit testing in Java or what have you, doing spies in Java or doing mock objects in Java is a bit of a nuisance because Java isn't necessarily really designed for that. But JavaScript is kind of neat in that if I want to replace a function, or if I want to test whether a function got run on an object, if I were in Java, what I'd have to do is use a generally a bytecode compiler library, something like BCL or aspect-oriented programming, to create a proxy that either creates a class that extends that class that I want to stub out a function on, or I'd have to use aspect-oriented programming techniques to plug in a before run or an after run. With JavaScript, it's actually a little easier and cleaner, because with JavaScript, a method on an object is nothing but a function that happens to be stored in a property. And in fact, any function can be replaced, and we can change the value of it. So the actual SPI mechanism is quite a bit easier in JavaScript, I mean, implementation-wise. And Jasmine supports this with a utility function, although, you know, if you wanted to replace a function in an existing object, it's like 4 lines of code in JavaScript. But just to make it really simple, Jasmine has a SPI on function that provides replacement. So we can plug in a SPI and then assert that, you know, the function we're talking about has been called, or has been called with a given value. So that looks something like this, where we have object equals, and here's a method on an object. So we're defining a function here. Let me just get my highlighter or my spotlight. Oh, oops. Spotlight. It's kind of funny. Okay, my spotlight's disappeared. Well, that's kind of odd. Okay. Pointer, spotlight. Okay, well, it appears I don't have a spotlight. You know, here's the object here with object equals method function value. I get a pen. So we're declaring a function value here. And then separately, you know, here we're stubbing out the method. So I'm spying on object method. And what I'm telling Jasmine to do is plug in a SPI object so that I can look at it later. And then as part of, you know, whatever test or spec that I do, you know, we end up calling that method, or technically or usually we're concerned that, you know, some part of the framework or some part of the code that we're testing called that method. And then I can use that in an expect. So I can say expect object.method to have been called with some parameter. So we can see what actually happened. We can kind of plug in a test harness to an existing object, which is kind of neat. And, you know, we can also set up replacements for the method. So we can say, you know, check that this method was called, but then go ahead and call the original method. That's the .end call through. Or I can just replace the method entirely. So, you know, if I want to build a mock object, I can simply replace its methods with return values that I want to, you know, replace. So I can say, you know, spy on some object, and whenever somebody calls the get some value, run my spy, but then return the value 777. So really, really useful, and the mechanism is pretty straightforward in JavaScript. We can also throw exceptions. So, you know, if I want to check that my code handles exceptions properly, I can, you know, throw an exception from some method. So, you know, I say if somebody calls faulty one, I'm spying on it, but throw the error ouch from that. There is asynchronous support that gets used a lot if you're testing something like Node.js code, server-side code. Not quite so much on Angular code that's running in the browser, because we don't tend to explicitly do asynchronous code. I mean, everything is asynchronous, but we don't tend to start things up in the background. But for reference, Jasmine does support asynchronous testing to make sure that things complete within a given amount of time, and also to make sure that they complete at all, and you know, organize asynchronous testing. So yeah, you can look into that in the Jasmine data. So as far as Jasmine goes, Jasmine's a powerful testing framework for JavaScript. Okay, and if you're writing any amount of JavaScript, you probably want to look into Jasmine or a similar framework. Jasmine itself doesn't really care about document object model, doesn't care about anything that's in the browser. In fact, Jasmine doesn't even care that you're testing code that would run in a browser. It's really only just using the browser as a JavaScript execution environment. But what if we actually want to test something, an AngularJS component? Well, in AngularJS, we can define unit tests using Jasmine, and Jasmine usually requires you to load a spec runner into browser, or we can run it under Node.js, whatever. But there's a couple add-ons that become kind of interesting with Jasmine. One is Karma, which we're not going to have time to look at in this, so I strongly recommend you look into taking the comprehensive Angular course. But then we can also use a product called Protractor to simulate user activities on the actual browser. So Angular's kind of neat in that it's designed for unit testing. Most of the work that goes on in the controller doesn't actually interact with the document object model. Okay, so we really don't have to simulate a whole lot to test the actions of Angular controllers and services. However, if we really do want to make sure it works in one or more browsers, we can do that. Karma tests across browsers, and Protractor simulates user activities on a browser. So that not only can we run unit tests, we can simulate clicks and data entry and mouse overs and what have you. One of the key components for testing Angular components is the Angular mock module. And primarily what Angular mock does, it simulates the Angular environment, primarily the dependency injection of the environment. Now, dependency injection is kind of a funny thing. The whole idea of dependency injection is to make it so that code is not coupled to any other code so that we can test it easily. And so any code that we have that is intended for dependency injection, by definition, we could call its constructor with, whatever injected values it needs and plug it in. But then it turns out that injecting everything is kind of a nuisance in our code. So it turns out that it's kind of nice to have a dependency injection framework that is working for us in testing the Angular code anyway. So we can use the Angular mock module that simulates Angular in or out of a browser and does all the dependency injection and simulates the Angular services. So we use the inject function in Angular mock to inject the items that we're going to test. In order to use Angular mock in an Angular test, we just include the libraries. And so from Jasmine, we just include the Angular mocks library in the spec runner. And obviously we still include our files, etc. Okay, so let's see about testing a service. Okay, here's an Angular service. So here I have an Angular module, my app, and I'm creating a factory for the my service factory. So a service, would be used as a back-end or a utility throughout an Angular application. And this service would have a method on it that has, say hello method that returns hello plus whatever name we feed into the method. Okay, so let's say we have that declared in a JavaScript file that we're going to test. In fact, here it is. Here's my app.js. So I've got my service. Right? So here I've got my Angular module, and I'm declaring a factory for the my service. Okay, all good. The unit test spec maybe, and you recognize this as Jasmine. I'm describing my app tests, before each module my app, I'm going to load the module so to work with Angular. So I'm telling the Angular mocks library to load up my app. And then I'm going to inject my service. Okay, so the inject, I'm going to provide it a function, and that function is going to get injected with whatever I call it, same as it would be inside an Angular app. And we're not going deep into Angular programming here, but hopefully you recognize that that pattern. So I'm injecting resources into this function. What's this function doing? Well, if we remember, the variables that we create inside an Angular or a Jasmine describe clause are available to all of the test clauses, all of the it clauses. So what we're doing is storing this injected my service, which is coming out of my app. And because we're using injection, Angular is going to set all that up and handle all its dependencies. So we're going to get a working instance of my service and then store it into SVC here, which is then available in this variable. Okay, so that's now available to the actual test expectation. Okay. What does that mean? Well, if we go look at the actual test, right? So here was myapp.js, and here's my app spec. So my app tests, and so before each module my app, I'm doing injection. I get my service and store that in the service variable, which then means it's available to use inside my assertion. Okay, and then just to kind of close the loop on that, there's Angular spec runner. I happen to put that in a different file that we're using, but we can see it loads up, and this one has 3 specs and no failures. Okay. So that's the unit test specification. Now, the one thing that people sometimes find a little confusing here, or not confusing, but it's a bit of a nuisance. See here, I've in order to make this service, in order to make this service available to the it clause, I've had to store it in a variable. So I created this var called SVC. That's different from what we would normally do in writing an Angular, a usage in Angular. We would usually use a variable that matches the name of the service. And, in here, we'd be injecting the function that's actually doing the work. And so I'd be using my service dot whatever. And that's convenient because you know where to look up, and if you follow the naming conventions, you know what file to look at. So we'd kind of like to, ideally in my expectations here, I'd like to know what service I'm using. But the problem is that my injected value here, the variable that's going to be injected, I have to store that somewhere else. I have to store that in the closure so that it's available to the actual test. And I can't use the same name, right? We're not actually in an object here, so I can't use this. So in order to make that a little nicer, Angular mocks gives us a little bit of a workaround. It says if you use a variable name, and if I surround it with underscores, it will strip off the underscores before it does the injection. So what we can do is something like this. If I say, so I'm actually injecting my service. If I were to come over here and put underscores in, okay, what it's actually going to inject is the service that's defined, by this my service factory, okay, because it just strips off the underscores. But now I can use this variable name underscore my service, and of course the underscore character is perfectly valid in JavaScript, which means that I can go ahead and call this my service and rename this variable to my service, and then use that inside my it clause, right? Which means that now it's unambiguous what service I'm testing within. I'm following the same kind of conventions that we do with Angular development. Okay, and again, just to kind of close the loop on that, if I come over here and you can see it still works, I still get the 3 spikes, no failures. Okay, so that's kind of a convenient thing for variable names for injection. Now, if I want to test a controller, I have a slightly different problem because controllers aren't subject to injection. The constructor of a controller can be injected, but there's no way that I can plug that in when I'm actually testing. So what I have to do, or probably more accurately, in an Angular app, the controller is instantiated when we use it in an HTML page, or when we use it in a page. There's no injection. I can't just have a function run that gets a controller injected into it. That happens in a couple of cases. If I had a custom directive, it kind of looks like I have a controller injected, but it's not actually injection. So what Angular provides us is a service called $controller that allows me to look up controllers by name and get a hold of a controller. So unlike a service, controller is not injectable. To obtain an instance of a controller, the first thing I need to do is get the $controller service, and then I can call the $controller service to give me an instance of the my control that I want, which is what we're doing here. And actually, let me just, so I can highlight the code, I'll come over here. So what I'm doing here is I have my before each, and what I'm trying to get a hold of is the $controller, okay? And then in my actual assertion clause here, I can assert $controller, okay, and look up my control, and then of course make method calls on the controller to find out whether it works or not. Okay. Things are actually a little easier if I have a this-based controller, because then I can just create an instance of the controller. Oh yeah, the other thing with controllers, we have to remember that traditional controllers, scope-based controllers, store their variables in the scope and will write data in there. So if we want to test that, here what we're doing is creating an empty scope and then instantiating the controller with $scope, or telling the controller to run it, and then we have to remember to call the methods and look for the variables in the scope. If I have a this-based controller, a more modern this-based controller, it's a little easier because the controller just stores it internally, so I can just call my test methods on the controller itself and also look up data in the controller itself. Protractor is kind of a neat thing, and we're sort of a little pressed for time, but just the one thing that the unit testing we've done so far, we're just testing in JavaScript. We're not actually testing with the document object model. This is a great feature of Angular because, for the most part, we don't have to deal with the document object model in either performance or testing, but in the end, we might want to actually make sure the browser acts the way we want it to. Okay, and there's the whole discussion on user interface testing and how fragile it is, and that's perfectly valid here. What we will say is that there are tools that allow you to test in the browser. So what we are now doing is end-to-end testing. So we're going to actually load up the page in the browser and see if it works. Well, I could certainly do that, in my browser. Here's my greeting page, here's my page. I can load it up and see if it works. Well, no problem. Pretty clearly, I don't want to do that as part of much of a development thing, because that requires a human being to be involved, and I'd really like to automate that. So how could I automate that and yet still run the app in a browser? The answer is Protractor. And Protractor is an end-to-end testing. It uses kind of a convoluted setup. It's going to run, Protractor runs in Node. And the actual test code runs in Node. But it makes use of a package called Selenium, the Selenium WebDriver, which interacts with browsers to interact with their automation interfaces to simulate things like key clicks and to read data out of the browser directly. So we have to load up the Selenium web browser. That runs under Java. And so, in order to run Protractor, we're going to need both Node.js and Java installed. Once we do that, we can install Protractor with npm install -g Protractor, do an update on the WebDriver Manager, and then we can find out, because I have it over here. So I could say Protractor -- version, right? So now I have Protractor loaded. Well, in order to tell Protractor to run something, obviously I need an application. But remember, if I were running this manually, I would just have a URL that I've loaded up, and here I'm hitting a server that I'm running. So I also need a server, and here I was using just a plain old Express server running under Node.js. Well, I'm going to have the same thing in Protractor. Here's a web page I'm testing. That's the page I just showed you. I write a simple test spec. Well, maybe I want to load up the browser, load up the page, and check that the title is equal to greeting page. Right? That's not showing up in any of my JavaScript testing. That's part of the HTML. So, maybe I want to check that. And the Protractor interface gives us, browser.get, browser.title, etc. And so I can write a test spec. Okay, how do I run it? I have to tell Protractor where it's going to find it, where it's going to get a hold of the Selenium WebDriver, and also what specs I want to run. So I create a configuration file called conf.js, and you can have many of these if you wanted to have different sets of specs, but because we're going to hand that name directly to Protractor. So here I have my conf.js for Protractor. In my case, I'm still using localhost 4444. That is the Selenium WebDriver, and I want to run this greetspec.js. The greetspec was, load up a URL in the browser, and then check that when I call browser.getTitle, it's equal to greeting page. Okay. From there, I can go ahead and run it. I'm going to have the WebDriver Manager running, so I call WebDriver Manager.start. Here it happens that I've already done that, so actually here is the WebDriver Manager. So it's sitting there running, and convoluted setup. Protractor is going to talk to the WebDriver Manager. WebDriver Manager talks to the browser, tells the browser to load the page and what to do, and then Protractor checks the outcomes, etc. In the end, I can run Protractor conf.js, and I don't know if this is going to stick around long enough that you can see it on the webinar, but let's try. There's the browser come up, and it's gone. It ran the spec, checked the value, and closed out the browser. So it actually loaded up the browser and ran it, and it was running it in Google Chrome, and you can set up Firefox, and I'm not sure if IE, certainly Safari can be supported in Protractor. So there's end-to-end testing, and you can check out the contents of elements and see what's actually in the document object model. So a little taste of testing with Protractor. Okay, and we can send user input. So here we can say get the page localhost 8080 greet, and then clear some input and send the keys for Daffy Duck, so I can enter a new name and check that the text changes appropriately. Okay. So that's integration testing. We looked at some integration testing tools. We looked at Protractor and Jasmine. And just to kind of come back to what we were trying to accomplish here, here's my slideshow. And, we can help you out with Intro to AngularJS, Comprehensive AngularJS, and Angular 2. That's it from me. Happy to take questions. I have some other offerings. And, we don't have contact numbers. Sorry about that. We should have had contact numbers on there. Anyway, we'll plug that into the final recording. So happy to take some questions, and hope you found the presentation useful. The recording and the slides will be made available to you. Thanks a lot for your time. Hope we can help you out in the future. Okay, so just to sum up, we've had a look at unit testing AngularJS. We had a look at the Jasmine framework, and then we had a look at some of the features of the Angular mock library, and finally looked at the Protractor framework for end-to-end testing. I have been Greg Trasick with WebAge Solutions, and do have a look at our knowledge base pages, and do have a look at our catalog pages. Thanks a lot.